All right, so we are going to continue in chapter 3. Let me share my screen right now. Okay. So we spent time looking at malicious software, right, yesterday. And we looked at, anywhere from, let's go back there. The different types of viruses, right? Viruses, worms, Trojan programs, right? So let's move on there and see what else we've got. Some of these viruses, let's just talk about that a little bit. Like it says here, right here. Some of these viruses are executable pieces of programming code. That is, they can, if you program them correctly, they can just run based on some action from the user, right? So, some of the viruses that come through email, for example, or are embedded in flash drives, you just need to take an action. Click on the link, install that flash drive or USB on your computer. There's an action that you take that may cause that virus to run. All right. So some, I guess, characteristics of viruses. And of course, we know that there is nothing good in viruses. They cause a lot of damage. Even if they don't damage anything, they can significantly slow you down, right? They can just mess up your whole work and your whole operation. You have to uninstall. Sometimes you do have to uninstall, an operating system because that system has been compromised. Now, it tells us right here, there's so many places online where you can find how to build a virus, right? So there's a lot of help there, I guess, for people who want to do malicious stuff. Okay. Worms are a type of malicious software. The thing about worms is worms have a way of creating backdoors, right? Can install backdoors so they can come repeatedly over and over and over again and perhaps affect that system. Okay. Also says at the bottom here that Trojan programs can use known ports. Wilderson, what are some ports that you know of? Right here it tells us of port 80, the HTTP port. What are some other examples of ports that you know of?
HTTP port 80.
Okay, so port 80 is here. Tell us some other ports that you're aware of.
I know HTTPS. Is it port 85?
You tell me.
You know what? The most common one for me is port 80. That's when we talk about. But
Wilderson.
Port 53. UDP.
Well, that's right. We can see that right here. So tell me a port that you know that is not right here. Tell me a different port. You're in the IT 444 class. That's an advanced class in IT at UMass Boston.
Yeah.
So you should know a few ports.
Yeah, I knew them, but I just forgot. Sorry. Let's see. I know port 85. All right. I think port 85 is HTTPS.
Port 85 is HTTPS. Right?
Yeah.
Okay. Angel, port 85 is HTTPS?
No, it's 443. It's the secure protocol of HTTP. It's 443.
Port 443. And that is for HTTPS.
Yep.
Okay, let's see a couple more ports that we're aware of. Angel, any other ports that you know of? Let me give you a clue here.
22.
You have
SSH.
FTP. Okay, you got SSH.
Yeah, I don't remember the FTP. Those are the three most common ones I know. It's 80, 443.
SSH is what? 20 what?
22.
Yeah.
Okay. FTP is what? Who knows what FTP is? You guys are seniors, right? In the IT.
20 or 21 for FTP.
Okay. All right, so here are some ports, right? We know that viruses, or should I say, people who are trying to, hack into your computer and do illegal stuff, always look for ports that can be compromised. If those ports are exposed with no protection, those ports can be compromised. So having it says a good firewall is an absolute requirement, because that is, if you don't have adequate firewall, you're looking at the potential for compromise on that system or that network. All right, so firewalls are places that an attacker is going to look at. All right. All right, let's keep going here. See a few more things. I want to go to. All right, so we talked about this also. We said, well, antivirus programs, have the ability to detect malware programs, and also you're looking at education. We talked about it yesterday. We're educating users. It says users who are not trained can open holes into a network, and no technology can protect against that. All right. So when we say users can open holes, all right, so what does that mean? Ibnut, what kind of, what does that mean, and what's an example of holes that a user can open in a network?
I would say if the network is not well configured, that could be, an open hole.
What does that mean? What do you mean well configured? How do you configure a network?
So for instance, I know it's gonna be hard, but let's say if there is no firewall at all, so that could be an open hole.
All right, so absence of a firewall.
Yeah.
Okay, so users who are not trained. So for example, you hire an IT person, right? You hire an IT person who's not very experienced on the job, and they try. Oh, absence. Is this the correct word? Is it absence with a? Is it an S or a C? I think it's a C, right?
I think it's a C.
It just looked kind of funny with an S. That's like absence. That's like sense, right? Okay. So what you might call it? So an IT person that is hired who's not very experienced, right? And you have them set up your firewall, and they don't do a good job, right? That might create some problems, right? It's like it might be something like what, something like this here. What's that now? Let's say you have, you know, you hire a security person, right? I mean, you can imagine that somebody who's supposed to be protecting your. Here's a good example, right? Let's use this. All right. So this guy is supposed to be protecting the company, watching out for, you know, issues, and he's taking a nap, right? So that's kind of like having holes in your security when the people or the devices that are supposed to be doing the work are not doing the work, right? So like you said, I mean, a security person who is asleep can be an issue. A firewall that is not properly configured can certainly be an issue, right? So hopefully, these guys who are asleep, you know, that's a vulnerability there. Because like you see in the movies, the bad guys are gonna come when these guys are asleep, and by the time the guys that, you know, wake up, the robbery has taken place. Too late.
Maybe that
Okay.
guy. Maybe that guy has a good firewall. That's why he's sleeping.
He has a firewall. What can? Okay. Here's a question for you. What can a firewall not? Okay. So what can a firewall not protect? Right? Can a firewall protect employees? Like if you're in the bank, can a firewall protect employees from like a robbery?
No.
Hello?
No.
Nope. So I know we're mostly talking about digital or network security, but physical security is it's a key part of any kind of security. Physical security. So in this case, with this guy asleep, well, you might have a very good firewall, but the criminals might just decide to just walk into the building and grab all the computers and disappear with them. So what's the point? What good would your firewall do? Right? So there's physical security and there's network security. And obviously in this case, the network security, the physical security is no good. All right? So educating your users is a vital part of protecting against malware attacks. Okay, so training, right? Training, everyone gets trained, employees and management get trained, recommended virus updating. These are the vulnerabilities that an attacker is going to take advantage of. Your employees are not well trained. They don't know what to do at different times. And then whitelisting is another strategy. Cindy, what is whitelisting? Explain it to us. Whitelisting.
It's when you only allow programs that you approve of to run on a computer.
All right, so what does that mean? Give us a practical example. If you're going to advise me on how to whitelist, what kind of practical example would you suggest?
Preventing users from downloading anything like from a suspicious website.
Is that what whitelisting is?
Oh, so would it be like not allowing like a suspicious website to be used?
So you just said now, Cindy, that whitelisting allows only approved programs to run on computers, right?
Yeah.
So how is that? Give me a practical example of that.
Oh, okay. So it's like if you were to when you allow only like certain things, like for example, Word.
Like Microsoft Word.
Yeah.
You said okay.
Excel.
Yeah, go ahead. Microsoft Word, Excel.
Safari.
Oh, Microsoft, not Microsoft. Microsoft. Okay.
Safari.
So when you allow, what happens? You allow Microsoft Word and Excel
to work, to run on the computers.
That's what whitelisting is.
Yes.
Okay. So programs that are not allowed cannot run, maybe until they're sort of verified or something, right? So that's what it's like. You know, Cindy, if you have a birthday party and you're going to invite people, and you say, okay, here's a list of people who are allowed to come to my birthday, right? So the approved list. So a way to control or to protect access to a computer or to a network is to whitelist. You have programs that are specifically allowed to run, not just any program, right? You specifically select programs, right, that are allowed to run, and you block every other program. Like no other program can run except Microsoft Word, and in this example, Microsoft Word and Excel. So only approved programs, right? Beyond program, well, that's what whitelisting is. But beyond programs, we've also got to get to the point where you're only allowing approved, maybe even approved people in some cases, to go to some certain parts of a building, right? Based on based on permissions. Who can get in here and who is not allowed to get in here, right? So that's the idea of whitelisting there. Okay, let's go on. Okay, let's look at some of these terms here. And we can find these terms in the book. We see them. Let's go on here. A page, if you have the hard copy, if you don't have the hard copy, well, it's about page 68, 69. All right, so attack. So an attack, the way it's described here, right, it says, it happens when a weakness or a vulnerability is exploited, right? When a weakness or a vulnerability is exploited. So when we use Cindy's example here, right, whitelisting. So if you have a program that is somehow, that is not whitelisted. So let's say, for example, you have something like, I don't know, let's say you have some antivirus program. Right, you have an antivirus program which has not been whitelisted. And somehow that program is allowed to run. Or maybe it is whitelisted, right? But it's known to have some kind of issues in that software. So if you whitelist a program that has potential for damage, right? Well, that becomes a weakness or a vulnerability, and it can be exploited, right? So if an attacker knows that, oh, you have this antivirus installed in your network, and that antivirus is known to have problems, right? Well, that's a weakness. That's a vulnerability that can be exploited. So exploited there, just like the word exploit, right, means to basically carry out your plan, right? It says specially crafted string of data intended to take advantage. So there's a vulnerability there, and you know about it, and you take advantage of it. You put your plan into action, right? So exploited, attack. You can probably use those terms interchangeably, right? When an unauthorized person is able to access network resources, you say that the company or the network is being attacked, under attack, right? And an exploit, right? You craft a particular package or an item which is designed to take advantage of a vulnerability. So when you find a vulnerability in a network, and that's what network people or security people try to prevent. You want to make sure there are no vulnerabilities in your network. And that's why we've talked about penetration testers. That's why you hire penetration testers, right? As a way to figure out in advance what kind of vulnerabilities might exist in a network, right? So we don't have to wait until there's an attack, right? Being proactive, that's the word, being proactive. Proactive. That is kind of in advance of something happening, you're taking steps, right? Taking steps before, should I say before an incident. You're taking steps before an incident. You're being proactive, all right? So attacks, exploits, computer security, and computer crime, right? I mean, if you guys are having your discussions during the week, and so you're going to be aware at different computer crimes that are being committed. Ransomware is like, right up top of the list right now, right? A lot of attacks on different institutions and organizations, right? Well, some of this things we're talking about in terms of vulnerabilities is what an attacker takes advantage of, right? To attack a company or a network is when there are things there that the attacker can find, right? So we can assume that if an attack is successful, there was we need to ask, what was it that the attacker was able to, how did they get in? How did they get in? How were they successful? You understand? So those are things that, is a concern for how intruders attack networks. Is how did they get in? What kind of vulnerabilities or weaknesses? We talked about it yesterday. We talked about backup systems, right? Backup systems. Without backup, there's certainly going to be a major issue without backup, right? So that's a strategy, right, for things like ransomware. So that even if your system gets locked down, right, you have access to your files, you have access to your data. And so companies need to invest in that. So if that was your job to make recommendations, well, you absolutely have to recommend that companies invest in backup systems, right? And not just throw money away by trying to pay for ransom. Stuff like that. All right? Okay, denial of service. And so we have denial of service and distributed. So there's DOS and DDoS. In whichever case, they're just kind of like a form of each other, right? Intended to cripple a network, right? Intended to cripple a network. All right. So let's look at DOS just a little bit here. So an example. Let me just read from what he has in the book here. So obviously, with DOS attacks, sometimes they're going to send, large packets, right? Large packets to a particular computer or a particular system. So here's an example that I always think about, right? When we talk about denial of service or even distributed denial of service, right? Now, distributed denial of service is when you use, when an attack on the host from multiple servers or workstations. So I always use an example of, let's say, Justin Bieber, for example, right? Taylor Swift, one of these, famous singers, releases a 2-minute clip on YouTube and says, "Well, you guys got to watch this clip, 7 o'clock on Friday, just for 2 minutes. That's my latest release." You can imagine what happens when a lot of people try to go watch that clip, at 7 o'clock on Friday, right? Rafael, what is going to happen? What do you think?
Would you repeat, Professor? I'm sorry, I was just opening this.
Say it again.
Would you repeat the question, please?
What was the last thing you heard?
I heard when you were talking about the Justin Bieber, but I didn't quite get the whole thing.
All right. So if Justin Bieber releases a 2-minute clip for his latest single and says, "Well, you guys go listen to that single on Friday at 7 o'clock," right? So a lot of people obviously, are quite curious. Oh, what does this guy have up his sleeve right now? So they go to YouTube at 7 o'clock. So Cyril, potentially, how many people are going to go and watch that clip? What do you think?
Millions of people.
Millions of people, right?
Oh yeah.
So what's going to happen? What's going to happen to YouTube at 7 o'clock on Friday?
Well, there will be like the network maybe like, I don't know, maybe gets like busy, like the network, everybody trying to access the clip.
Yeah. The network is definitely not going to be able to handle that kind of traffic because normally there's an amount of traffic that you can handle. So now if we have all this traffic coming almost at the same time, right? Does it affect the system? Will the thing? Does it affect any system, right?
Yes, it does.
So that's kind of like what distributed denial of service is. When an attacker, right, is able to sort of get a hold of multiple devices, like a lot of devices, right, using them as sometimes called zombies, right? It just grabs those devices and uses them to attack a particular system. Sometimes it floods them with a lot of requests, like simultaneously, like at the same time, right? I mean, it might be hundreds of thousands of servers or workstations. The system is going to suddenly go down, right? So your service will be denied. So YouTube is suddenly going to be affected if that was if that actually happened. until they get everything restored or get everybody off, off YouTube for a while, right? So there's a certain amount of traffic that a network can manage. But when there's like an unusual amount of traffic, it definitely is going to bring down that system. So imagine if an attacker was somehow able to release some kind of some advertising, right? And says there's going to be this, YouTube clip. Somehow they're able to get everyone's, Facebook page or however, somehow they just put out a fake message, right? That is suddenly going to affect that particular network, right? So strategies that an attacker might use to compromise the system might be to spread false information, and then everybody moves in a certain direction with the aim of bringing down that network. Okay? So that's a real thing. It's also kind of also similar to buffer overflows, right? There's a certain amount of, let's see what it says it here. Yeah, a program might be allowed to run on a particular amount of, say, a particular size, right, in memory, right? In the computer memory, you might say this program, right, for example, the example we have in the book there, right, the way it goes here, it says in a buffer overflow attack, right, an attacker finds a vulnerability in a poorly written code that doesn't check for a defined amount of memory space, right? So there's amount of memory space. It's kind of similar to, DDoS, as it's referred to, where you have a certain amount of traffic, right, that you can allow, but it just gets overwhelmed. Too much, right? So with buffer overflow, it doesn't check for the amount of memory space used. It's like if you go to your task manager, right? If you open up your task manager, right, and you look at some of the information that you find there. Now, for what you guys can see, which program here is consuming a lot of resources?
Zoom.
Mahad. Where's Mahad? Is that Mahad? Who is here whose name is Mahad? Who is here whose name is Mahad? If you don't respond, I'm going to assume you're an intruder and I'm going to kick you out of the class. So whose name is here called Mahad? M-A-H-A-D. Are you guys hearing me right now? Or am I talking to myself?
We are here.
We hear you.
All right, so
Mahad's
are you
not
seeing a name?
Mahad trying to do a DSS on you.
So is there a Mahad here?
I don't think there's a Mahad.
You don't see a name here, M-A-H-A-D?
No, I mean, like, I don't know if he's in our
We
class.
see the name.
Say that again?
We see it, but we don't know who it is. Maybe somebody from the school trying to monitor what you're teaching.
A monitor from the school. Okay, Mahad, you're going to be kicked out right now. So if you are a person, you better speak up right now. Okay, there's no response. So I'm going to, with a flick of my mouse, I'm getting rid of this Mahad person. Should I do that? Right?
If you do that, they still can come back. You're still gonna have the same
No.
link. No.
No coming back. I
Oh
mean,
my
how are you going to
God.
be here and you don't respond? We spent the last 2 minutes talking about this.
Maybe my had step
Okay.
away.
Maybe he's in the bathroom.
No. That kind of bathroom break, that's like a major hospital problem.
Let's go, Mahad.
Okay, bye, Mahad.
And he's the only person that has one. Like everyone else has a full name, first and last. He doesn't.
That's so suspicious, right?
Yeah.
Okay.
Oh wait, I do. Wait a second. I have my only name.
Well, it's too late. Mahad is gone. Okay, so what was the question? You see, this is a lot of distraction right now. So the question was, what was the question? I forgot the question.
Mahad, if you don't respond, I'll kick you out.
Mahad is gone. What was the question
Okay.
we were trying to ask? I forget.
Any of the applications consuming a lot of data.
Yeah, I think
I don't remember the question.
You open.
I've lost my train of thought.
You open all
the tax
applications
manager
running on your platform on a computer.
Oh yeah, exactly. Okay, thanks. So where's Tax Manager? Let me go back there. Yeah. All right. So a simple question, right? Which of these resources right now, Michael, is consuming a lot of power?
It's a Zoom.
Or resources?
Zoom meetings.
Exactly. So this could be like if you had a kind of a system that monitors activity on your network, not Task Manager, but there are certainly a lot of tools that are similar to that, right? That helps you look at your traffic. And so if you notice that, wait a minute, how come this program is consuming so much of our resources, right? Then you could, it will help you. With Task Manager, you can see like a live view of what is happening on your system. So let's say, for example, I didn't need Zoom. I could just right click here and end the task. Well, don't do that because it's going to kick you out. But if I didn't need to use Zoom and I noticed that it was taking up all my resources, I could just get rid of it. So that's kind of like buffer overflow. There's a certain amount of memory, that a program should use. Sometimes it just overflows, right? Overflows. Okay. Let's see what else we got here. So here's some examples of buffer overflows. Let's see. So this example here, so it talks about this ghost example. So look at the vulnerability there, right? It says that a library in Linux operating system called glibc, right? So this ghost application was able to take advantage of that, and there was a buffer overflow situation, right? So they can be sure that monitoring your network and stuff like that is an ongoing 24/7 responsibility. Here's another one here from Cisco ASA Internet Key Exchange. It says attackers were able to send a specially crafted packet to the affected device, which will allow them gain full administrative privileges. And then this attack will take care from anywhere on the internet, right? If ASAs, so there you go. So we're talking about vulnerabilities here, and buffer overflow is certainly one of those. Okay, eavesdropping. Michael, what do you understand by eavesdropping?
Spying.
Spying.
Yeah.
So let's say you're on a bus. You're going home from work.
Yeah.
Right?
Yep.
So, is it possible to eavesdrop on the boss?
Yeah. I can
You
put my
listen
head
to
in it.
what the person behind you is saying, right?
Yeah. Can stick my nose and eyes into people's business, especially their cell phones and others.
Exactly. You stick your nose into people's businesses.
Yeah.
Here it says that eavesdropping is like when you intercept confidential information, right? You can use that in an attack. Eavesdropping, trying to listen. That's what it says. On an unencrypted network communication. Unencrypted. Right? So, the example you guys talked about earlier, if you have a website, that is a HTTP website, can you eavesdrop on a HTTP website? Absolutely, because the HTTP website has no encryption.
Yep.
Right? There's no encryption there. If I do a search here and I say, what's that favorite page? Last page on the internet. Right? So this page is called the last page on the internet. Now this page here, if you look at the security options, you can see that it tells you that the connection is not secure. Right? It says your connection to this site is not private. Information you submit could be viewed by others. Right? Now here's the question, Michael.
Yes.
Should I be going to a website like this?
No.
No? So I should right away close this site?
Yep.
Okay. So I should never visit a site like this. If I do, I might be compromised. Is that what it's saying here?
The HTTP site, like literally, I think almost all the sites are now going to HTTPS because it's no more secure. Most attacks.
Wait a minute. Didn't we get rid of this Mahad person? Can you?
Hi, Professor.
What? That's a person? Who is Mahad?
Yeah, I'm here, Professor. I can hear you right now.
Who are you?
My name is Mahad Torre.
What's your full name?
Mahad Muhammad Torre.
I am confused right now. Where were you for the last 3 days?
I was here. I did take your class here for the first class, and then on Monday it was we were doing on lab to Mintab.
Okay, wait a minute. Where have you been the last 10 minutes? Because the whole class has been trying to talk to you. Where have you been?
Oh, Professor, I had a kind of connection problem, so I'm in restaurant right now using for public Wi-Fi.
So did you notice that you were kicked out of the meeting?
No, I thought that the network kicked out because it was I was in and out.
Oh boy.
What
okay. I don't know. Everyone thought you were an intruder or a spy.
No. I'm in the glass. Sorry about that.
Okay, not a spy. All right, so you tell me, Mahad, is it a problem for me to come to a website like this?
Let me read. No, it's not safe to be in this website.
So I shouldn't be visiting a website like this that is just that has no security, right?
Yeah, 100%.
Huh. Surafel, if I visit a website like this, is this a problem for me?
It's not a problem, like to visit the website. I think to see the website.
That's not a problem.
It's not a problem, but as you said, like maybe submitting. If you leave your information or you submit your information, as you mentioned, everybody can see it, and that's a problem.
So, Michael, what do you think of that? The problem the problem is not about going to the website. You see
I
what
think
it
there's
says
a
here?
problem.
You see what it says here?
It makes
It
it
says,
unsecured.
hang on. It says your connection to the site is not private, right? What does that mean? Information you submit could be viewed by others. So it's not about coming to the website. It's about submitting information, passwords, messages, credit cards, stuff like that. So visiting the website doesn't mean that you're unsafe, but if you submit information, like if they tell you you want to buy a computer, you want to buy a mouse, put in your credit card information, that's a problem because you are exchanging information. How does that sound to you?
Yeah, I think it makes sense based on the explanation you just gave. But my point is sometimes, what if hackers are using that as a loophole to maybe spy, as we just eavesdropping, just they are on the side, eavesdropping on people. So once, for instance, people have their credit card and other stuff saved on their computer. For maybe you accidentally click on something, or there's a malware or whatever phishing stuff link over there. They just, if you accidentally hit on it, and pretty much you are putting yourself at a risk. So once you open and it says it's not secure, it's not private, I think the best way is to just close it.
Okay, but I don't want us to get things wrong, right?
Yeah.
I want us to have a good understanding of this topic. Okay, so here's an example, right? Let's say, let me show you guys something here. Let me go here, show you guys something here. Okay, so let's say, no, let's do this. Okay, now look at this here, what I just did here. How to create a virus, right? Okay, let me go to this site. Okay, now let me stay with you, Michael. Now, see the information I'm reading right now,
Okay.
right?
Yeah.
How to create a basic computer virus.
Yeah.
Is this a good thing? Like, it's telling you how to create a virus, which can probably be used to, give some people some serious problems, right?
Yeah.
Now, this is a secure website.
Yep.
So, I think that we think that if a website is so-called not secure, that everything on that website is bad. But if a website is secure, then everything on the website is okay.
No.
That's not accurate.
Yep.
Right? It's not exactly about the platform, it's about what you do on the platform. So you can go to a secure website, right? Where, websites on the dark net are secure because they don't want you to find them. They want to be able to commit all their crimes or do all this illegal stuff without being discovered. They are secure sites, right? A secure site means that if you exchange information, that information cannot be detected. It doesn't mean that the information you're transferring is good information or clean information or some kind of acceptable information, right?
Yep.
For example, the pipeline attack that we talked about, if you guys are already in the news, the FBI was able to recover a lot of the money, right? But when I read about it, the money was paid to them in Bitcoin, and it was routed through so many different bank accounts around the world, from this account to that account to that account. The FBI had to do some serious work, right, to trace the money, right, until eventually they found out, somewhere where they could, get the money back. So a secure platform doesn't mean that all the information there is all nice and lovely. It just means that the information you exchange, right? Nobody else, as much as possible, is going to be able to get a hold of it. So very important to understand that, right?
Yeah.
Because if you're doing bad stuff, well, you don't want people to know about it. You know what I'm saying? So you're going to go to a secure site.
Sure.
Also, you said something about, when you're on a site like this, maybe if you had files on your computer or something, well, somebody could gain access to it. People don't just gain access to you magically. There's an action that you take. It might be unintentional.
Yeah.
But people don't just reach into your computer and just grab stuff. You must have allowed something. Click on the link, downloaded the file to allow access.
Yeah.
Angel, what do you think about that? People just reach into your computer, like some of the
maybe you
images you see here.
That's what I said.
Oh, okay.
No, they can't.
Where's that example? I like some of the examples I see here when people can just something like this, right? You have to have done something to give the access.
Sure.
Right? All right. That's what I forgot before we go to Mind Tab. So eavesdropping, man in the middle, that's another form of trying to intercept your information, right? Pretending to be the real thing, but they are not. Pretending to be the real thing. Just like network session hijacking, right? The attacker makes both parties think he or she is the other party, right? Okay. Like I said, physical security is also a key part of security in general, right? It might be things like, keyloggers, right? Keyloggers affect your computer, the ability for programs to be installed or software to be installed on your computer so that your computer, your keystrokes on your keyboard, it says it right here, your keystrokes can be retrieved or emailed or transferred to a remote location, right? So that affects your hardware, your actual computer, all right? So when we talk about vulnerabilities, for example, being able to, here's an example here, something I showed the other class, I think. Lockdown PCs, right? So when you have computers, where is it? Okay, well, I'm getting images we don't need here, but here's an example. I'm not seeing the picture I want here. I see Kensington. Is it Kensington? Kensington lock. Okay. So here's an example, right, of some kind of computer security, or maybe that's not a great picture, maybe a better picture, someone we can see properly. All right. So you might see examples here, right, of where you're able to lock down laptops and computers, so they cannot be physically removed, physically taken away, right? In a public place, you might find laptops or computers that have been locked down to prevent them from being removed from their physical location. All right? This is all part of security. This lock here, Fanzine, you know what this lock is called? If you work in a company and they tell you we need some locks for our laptops, Fanzine, what's this lock called?
I don't know. Maybe it's IP lock code. I don't know.
Maybe what?
It's a lock for your IP address. I don't know. What's this name?
A lock for your IP address?
I'm not sure.
What are you saying?
Because you asked me what's this for lock for.
What's the name of this lock? This lock is used to lock down laptops so you can't take it away. This lock here, look at the name here. You see this name right here?
Kensington. I don't know. I first class.
The Kensington lock. Kensington lock. It's used to lock down computers. Okay? All right,
Okay.
last thing here before we go to MindTap. Let's see. We talked about keyloggers already. And also actual door locks, right? It says locking up server rooms, deadbolts or, whatever appropriate locks that are available, right? At the bottom there, it talks about keeping the record of who enters and leaves the room, right? Security cards. You want to know who was in the building when this stuff happened, right? If something goes wrong, you've got to have those kind of logs. Who was in the building? Does anyone walk in a place? Well, I don't know about the pandemic, but does anyone walk in a place where you need an access key to get in or access card? Anybody?
Yeah.
Tell me about it. If not, what you got? You guys use a card, right?
Yeah. So at my job, like before you get the card, I think it took about 5 months just to get the card due to security.
Oh, they have to do a little background check.
Yeah.
Wow.
And once you get it, you just go ahead and you swipe it on the chip, and then you get inside the building.
So what happens if you don't pass the security check during the 5 months?
Oh, the thing. What I did was I had a coworker, the trainer. I got their phone number, so whenever I'm outside, if nobody is walking in and out, for me to take the chance to go in, I just call him, and then he came out and then opened the door.
Wow. That's interesting, right? That's a lot of stress, but it's for security, right?
Yes, exactly.